Hey guys, all right, welcome back. That's pretty funny that this happened. I wrote it right, but then graphed it wrong. The y-intercept was 0, -4, that's what I said, but then for some reason I graphed 0, +4. So it should have been down here. And so my graph should have been all of this. So there's my much narrower graph. I knew when I had a wide graph something was wrong, but I couldn't quite figure out what I did wrong. Okay, so here we go. Let's go ahead and solve some of these algebraically now instead of graphically. Here's my first example. All right, we're going to solve algebraically. All right, now there are a couple ways you can go about doing this. It's basically the same way. If it would say an equal sign, you would solve it the same way, okay? But since it's an inequality sign, we need to show all of the solutions on a number line, and so I'll show you how to do this. Now there are a couple different ways you could solve this. Let's just since we could take the square root of both sides, let's just do that, okay? So move the 4 over, divide by 4, so we're left with x squared is less than 25 divided by 4. Now we can take the square root on both sides, okay? Don't forget your plus and minus, okay? And so x is less than plus or minus 5/2. All right, and so this is where it gets pretty abstract. X is less than positive 5/2 and less than negative 5/2. I don't get what that means, okay? So here's what I do. I consider these guys checkpoints. So this is what I'm going to show you. If you do it this way, I think you'll be good. These are my checkpoints, okay? My checkpoints are 5/2 and negative 5/2. And since it's an inequality, we have to show our answer on a number line. Okay, so here's my number line. And on that number line, I usually put 0, but I'm also gonna put 5/2 on the number line and negative 5/2. Okay, don't be confused, that's really 2.5, that's really negative 2.5. Okay, since it says my x is less than, okay, 5/2 and less than negative halves, I know it doesn't equal those guys, but these are still my checkpoints. They need to be just kind of like the parabola that we were doing. When it wasn't equal, remember how we put a dotted line, okay? It's the same kind of idea here. If it's not equal to, we can't count it as a solution, but we're definitely going to make a note of it by putting a circle around it, an open circle. Same thing with this guy too, okay? And so now all we have to do to figure out where all of our solutions are is just check a point, okay? It's either going to be in between the two dots or on the outside of the two dots. Every single time, it's either going to be in between them or on the outside of them, no matter what. So let's just pick a point that's easy, or pick a value that's easy to plug in, like 0. Take that 0 and plug it into the very start. 4 times 0 squared is 0. Is 0 less than 25? Yeah, 0 is less than 25. So we know 0 is a solution. Okay, so that's where our solutions are. Our solutions are in between the two checkpoints. Okay? All right, let's try another one. We have x squared minus 11x greater than or equal to negative 28. All right, one thing I notice, it is quadratic, okay? There's an a term, a b term, and a c term. Let's just go ahead and make it all in standard form, equal to 0. So bring that 28 over. So we get x squared minus 11x plus 28 greater than or equal to 0. Okay? One thing I want to remind you of, let's go back here. Remember when I divided by 4 to the other side? Do you remember that if this was a -4, if I divided by a negative, what happens to that sign? Okay, keep in mind you'd have to flip the sign. That's just some review for you, okay? Over here I didn't have to worry about it. I added a 28. You don't have to worry about flipping the sign unless you're multiplying or dividing by a negative. All right, so here we go. This, I can tell right away that it factors. If you don't want to factor, use the quadratic formula. That's cool. All right. But I think factoring is your best bet. So check this out. I'm going to go ahead and put parentheses here. Greater than or equal to 0. I have an x. Factors of 28. 7 times 4, right? Because this guy times this guy has to give us 28. So I'm going to say 7 times 4. Okay? Multiply the insides. That's 7x. multiply the outsides, that's 4x, all right. Can I add those together to get negative 11 of the x's? Sure, if they're both negative. So negative goes with the 7, negative goes with the 4, we're good to go. So now I know that x minus 7 equals 0 and x minus 4 equals 0. Now I know I said equals, it's really greater than or equal to, but like I said, I'm only going for checkpoints right here, okay? So x equals 7, x equals 4. These are my checkpoints. All right, those are just the checkpoints. So I'm going to make a number line, and on that number line, I'm going to put those 2 points, like 4 and 7, okay? I'm also going to put 0 just for reference, okay? All right, now, the checkpoints. Is 7 a solution? Well, it says greater than or equal to, so yeah, 7 is a solution, okay? And what about 4? Greater than or equal to, yeah, so 4 is a solution. So we put closed circles there because we know that these 2 checkpoints actually are part of the solution. Unlike here, remember we got the checkpoints 5 halves and negative 5 halves? They weren't points because it only said less than, so we could not include those as solutions. All right, and finally, remember I told you that the solutions are either going to be in between them or on the outside of them. So if there's solutions here, we're also going to have solutions here. It's either in between or outside, okay? So I'm going to choose a point like I usually do. I like to choose 0. I plug 0 in, ready? So plug a 0 in here, 0 minus, plug a 0 in there, 0. 0 minus 0 is 0. Is 0 greater than negative 28? Yes, 0 is greater than negative 28. So this is a solution. In fact, all of the numbers on this side are solutions, and not here, but yes, over here, all the numbers over there are solutions as well. All right, guys, good luck. I'll talk to you soon.